everyone. In this video, I'd like to talk to you about sequences and describe what is a sequence and what are some examples of sequences that we commonly encounter. Okay, so a sequence is simply an ordered list. So if you're a computer scientist, we like to make lists or arrays, and we put elements in different positions, and the order is certainly important. And the same is true for our sequence. So a sequence is an ordered list, and it could be a list of numbers, a list of shapes. It could be a list of locations that somebody with a cell phone visited and we're tracking that data for some reason. So a sequence is really an ordered list. And for our purposes in discrete math, we will often talk about a list of numbers, an ordered list of numbers. But keep in mind, a sequence could be more general. All right, so let's talk about three examples, and then maybe I'll give you a couple of additional ones as well. The first example that I'd like to talk about is called an arithmetic sequence. And an arithmetic sequence is a list of numbers where there's a common difference between the terms. So let's look at an example here. So an example would be something like 2, 5, 8, 11, 14, and so forth. And if you look at the sequence and you play the game, find the pattern or find the next term in the sequence, what you might notice here is that each time to get from one number to the next, we are adding 3. Right? To go from 2 to 5, I added 3, or the common difference between those two values was 3. And the same between the 5 and the 8, and the 8 and the 11. So the pattern is called add 3, or that there's a common difference between all the terms. The difference between every term is 3, and we call that value D. So I'm just going to label this D equals 3. Let's look at another example here. We could have something like 2, 1, 0, -1. -2, and so forth. So we could have some negative values appearing, and that's perfectly okay. But we ask ourselves the same question again, is what is the common difference, or what am I doing to hop from one term to the next? And the answer here is I'm subtracting 1. Right? So the common difference between everybody is -1. If I subtracted 0 minus 1, I would get -1. So the common difference here is -1. All right, so anytime you have a sequence and there's a common difference between all the terms, that's what we refer to as an arithmetic sequence. Let's move on and talk a little bit about geometric sequences. So geometric sequences are lovely to play with, and they occur in lots of applications, especially when we're thinking about credit cards or home ownership, debt, unfortunately, or payments on things, or perhaps an epidemic spreading, unfortunately. But a geometric sequence, the basic idea is that we've got a common ratio. All right, so suppose I started off with something like 1, and then the next value was 2, followed by 4, 8, 16, 32, and so forth. So in this example, it's not that I'm adding the same value every time. So this is definitely not an arithmetic sequence. There's no common difference here. But there is a common ratio. So if I do 2 divided by 1, the ratio there would be 2. And similarly, the 4 divided by 2, the common ratio would be 2. So it's as if I'm multiplying by 2 every time. Same thing here. I'm multiplying by a 2. I'm multiplying by 2. So the common ratio is 2. Let's take a look at another example. Suppose I had something like 3, 1, 1/3, 1/9, 1/27. Nobody likes fractions. So if you're watching the video, you're probably mad at me because I put fractions in here, but that's okay. We know and love fractions. They're fine, just a little bit more arithmetic to keep track of. But the common ratio here, what are we multiplying by each time? So how did I get from the 3 to the 1 or the 1 to the 1/3? Well, the common ratio here would be 1/3. I'm multiplying by a 1/3 to get to the next term. Now, the Fibonacci sequence has so many interesting properties, including properties that are related to the golden ratio, Pascal's triangle, and all sorts of things. And I will leave some of those properties for our class discussions. It would be fascinating to look at some of those properties because they're one of the most beautiful aspects of mathematics. So, at least in my opinion. So for the Fibonacci sequence, we're going to start off with 1, 1, and those are given to us. And then we begin adding the 2 previous terms. So 1 plus 1 gives us 2. Then I add 1 plus 2, and that gives me 3. 2 plus 3 gives me 5. 3 plus 5 gives me 8. 13. 21, and so forth. And those are the Fibonacci numbers. And so there is no common difference. There's no common ratio. The rule here is a little bit different. And so the rule here, I just said, is adding the 2 previous terms. So in the next video, I'm going to talk about explicit formulas, recursive formulas, and we will actually come up with mathematical ways of describing these sequences.